Hello, in this lesson we'll be looking at how numbers behave when you multiply them by themselves. Let me show you. I'll pick a number, say 7. Now if we multiply 7 by itself, we get 7 squared. And this is written as 7 with a little 2 up here. Now multiply 3 7s together and we call this 7 cubed, with a little 3 up here. Now we call this little number the power or index. So 7 squared is 7 to the power of 2, or 7 times 7. 7 cubed is 7 to the power of 3, or 7 times 7 times 7. Now square and cube are the only powers or indices that have special names. When we get to 4 7s multiplied together, we call that just 7 to the power of 4. And that system of names works for all powers. 7 to the power 2, 7 to the power 3, 7 to the power 4. The next in order is, of course, 7 to the power 5, and that just means 7 multiplied 5 times over. So 7 times 7 times 7 times 7 times 7. Now this diagram is quite nice, but it suggests that we're missing something. What might we put in this space here? Well, to keep the pattern, it looks as if we ought to write 7 itself as 7 to the power 1. And we can do that. But can I convince you that 7 to the power 1 makes sense? Well, I think I can. The easiest way is to say something like 7 to the power 3 means write down 3 7s and fill the gaps with multiplication signs. So 7 to the power 1 means write down 1 7, and since there aren't any gaps, just leave it at that, just 7. But there's an even better way of convincing you. To see what that is, we have to do some work on multiplying powers first. Now if I asked you what 7 to the power 2 times 7 to the power 3 was, you could work like this. Now 7 to the power 2 is 7 times 7, and then you'd multiply that by 7 to the power of 3, which is 7 times 7 times 7. There, what's the answer to this? Altogether there are 1, 2, 3, 4, 5 7s. So 7 to the power 2 times 7 to the power 3 is the same as 7 to the power 5. And of course I'm sure you spotted the easier way to get that answer. You simply add this 2 to this 3, and that gives you this 5. So that's a first really helpful rule. To multiply powers of the same number, add the powers. It's really important you remember that this only applies to powers of the same number. So this rule allows you to work out that 6 to the power 4 times 6 to the power 2 is 6 to the power 6. Just add the 4 and the 2 to give you 6. But this rule is no good for a sum like 5 to the power 2 times 3 to the power 4. Well, of course, you can work out what this comes to, but this rule is no help. Because this is the number 5 to the power of something, and this is the number 3 to the power of something. So this rule doesn't work here. And neither is this rule any good for 5 to the power 2 times 3 to the power 2. Even though these powers are the same, they're both 2, the rule only works when you're working with powers of the same number, and these are different. Once again, you could work this out, but you can't use this rule to do it. So our rule gives you a quick way of multiplying powers of the same number. Well, how does that help me convince you that 7 to the power 1 is just 7? Well, we've got a little way to go yet. Now, if I ask you what 4 to the power 2 times 4 to the power 3 is, you can use our new rule and write the answer down straight away as 4 to the power 5. But suppose I divide both sides by 4 to the power 3. So now on the left hand side of the equal sign I get 4 to the power 2 times 4 to the power 3 divided by 4 to the power 3. And on the right I get 4 to the power 5 divided by 4 to the power 3. Now on the left I've used divided by 4 to the power 3 because division is the inverse of multiplication. So the left hand side just becomes 4 to the power 2. So 4 to the power 2 is equal to 4 to the power 5 divided by 4 to the power 3. And there's another rule for us there. To divide 4 to the power 5 by 4 to the power 3, you just subtract the powers. 5 take away 3 gives us 2, this 2 here. So we've got another rule for handling powers. To divide powers of the same number, subtract the powers. That means that if I ask you for 6 to the power 7 divided by 6 to the power 2, you can write the answer down straight away as 6 to the power 5. 7 take away 2 gives 5. Just as with our rule for multiplication, it's important that you only use it on powers of the same number. So 5 to the power 2 divided by 3 to the power 4 isn't a sum that you can do with this rule. And you can't do 5 to the power 2 divided by 3 to the power 2 either, even though the powers are the same. Just as before, it's the numbers that have to be the same before you can use this rule. And now I can convince you that 7 to the power 1 is just 7. If I gave you the sum 7 to the power 3 divided by 7 to the power 2, you'd use our new rule and write the answer down as 7 to the power 1. But what calculation have we done? Well, we've taken 3 7s multiplied together and divided by 2 7s multiplied together. Now a division by these 2 7s cancels out 2 of these 7s, leaving us with just a single 7. So the calculation gives us just 7, and the rule gives us 7 to the power 1. So you ought to be convinced now that 7 to the power 1 is just 7. And of course that works for any number, not just 7. So 3 to the power 1 is 3. 5 to the power 1 is 5. Now this new rule allows us to do even more. What do you think 7 to the power 0 is? Well, here's a way to find out. Think of a division sum that will give the answer 7 to the power 0. Now I've chosen 7 to the power 1 divided by 7 to the power 1. When we use the rule, the answer is 7 to the power 1 minus 1, which is 0. So this is what we're looking for, but what is it? Well, on the left we've got something divided by itself, and dividing anything by itself, the answer will be just 1. So 7 to the power 0 is just 1, and in fact that's true for any number. 3 to the power 0 is 1. 5 to the power 0 is 1. Any number at all to the power 0 is 1. This is amazing stuff, and we're not finished yet. What do you think 7 to the power negative 1 is? Well, you work the same way. Think of a division sum that gives 7 to the power negative 1 as the answer. I've chosen 7 to the power 0 divided by 7 to the power 1. When you use the division rule and subtract the powers, you get 0 minus 1, or 7 to the power negative 1. But what does that mean? Well, 7 to the power 0 is just 1, and 7 to the power 1 is just 7. So when you divide these, you get 1 divided by 7. So 7 to the power negative 1 is just 1 divided by 7, or 1/7. By the way, the rules we have for adding and subtracting the powers when we multiply or divide work just as well with negative powers as they do with positive ones. It's not just 7 to the negative 1 that has a meaning, all negative powers make sense too. To see that, I'm going to give you a third rule for working with powers. If I asked you to square 7 to the power 3, I'd be asking you to multiply 7 to the power 3 by itself. Using the multiplication rule for powers, you would add 3 and 3 and get 6, giving the answer 7 to the power 6. But there's an easier way of getting this, because to square a power of a number, you multiply that power by 2. 2 times 3 gives 6. Now how does that help us with 7 to the power negative 2, say? Well, 7 to the power negative 2 must be 7 to the power negative 1 times itself. The squaring rule tells you to multiply the negative 1 by 2 to give negative 2. But you've just seen that 7 to the power negative 1 is 1/7. So 7 to the power negative 2 is 1/7 squared, or, which is the same thing, 1 over 7 squared. Now in fact that's just one example of a very powerful rule. Any number at all to a negative power is 1 divided by that number to the same positive power. So not only is 7 to the power negative 2 equal to 1 over 7 squared, as we've just seen, but 5 to the power negative 4 is the same as 1 divided by 5 to the power 4. Now we've done a lot of work in this lesson, but out of it we've got some really useful rules. Let me just remind you what they are. The multiplication rule tells you that when multiplying you add the powers. So for example, 5 to the power 5 multiplied by 5 to the power 3 equals 5 to the power 8. To divide, you subtract the powers. So 5 to the power 5 divided by 5 to the power 3 gives you 5 to the power 2, or 5 squared. Any number to the power 1 is just that number itself. So 5 to the power 1 is 5. And any number at all to the power or index 0 is always just 1. So 5 to the power 0 is 1. To square a number with a power, double the power. So 5 to the power 5 all squared is equal to 5 to the power 10. And finally, the rule we've just seen. Any number to a negative power is 1 divided by that number to the same positive power. So for example, 5 to the power negative 3 equals 1 over 5 to the power 3, or 5 cubed. So there's a lot to practice there. Good luck, and I'll see you in the next lesson.